Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 4, Section 2, Organizing Data with Matrices. So in Section 1 we got an introduction to matrices, so today we're going to do a little more with them. We're going to learn how to add them and about their dimensions. First thing you need to know, equal matrices have exactly the same dimensions. And when that is the case, their corresponding elements are equal. So if you were given the fact that these two matrices are equal, could you find A, B, C, and D? Well, sure. This entry A is the same as this entry, which is 7. 2B here is equal to -8, therefore B is -4. Here to find C, we'd have entry 3 is equal to C minus 5, therefore C is 8. And these last elements here, we have 3D is equal to D plus 6. So we remember from our Algebra 1 days that we can subtract a D from both sides, and we would find that D is 3. So when two matrices are equal, their corresponding elements are equal to each other. Now this has 5 stars, so it must be really important. So notice here that only equal matrices can be added or subtracted. And to do that, you combine their corresponding elements. If you're adding them, you add the two elements. If you're subtracting them, you subtract them. So if you're asked to add or subtract matrices that are different sizes, it can't be done. So the first example, we're given matrix A and B, and we're asked to find A plus B. So we simply add the corresponding elements. So I have 2 plus 4 is 6, 7 plus 2 is 9, 0, and -1 is -1. 3 plus 1 is 4, 1 and -2 is -1, and 5 and 3 is 8. So there's A plus B. Now let's find A minus B. 2 take away 4 is -2, 7 take away 2 is 5, 0 minus a -1 is 1, 3 minus 1 is 2, 1 minus a -2 is 3, and 5 take away 3 is 2. So there we have A minus B. Next we're going to talk about an identity matrix for addition, and this isn't very exciting. An identity matrix for addition is simply made up of zeros. Whatever the dimensions are that we're talking about, if we're talking about a 2 by 4 matrix, this is its identity matrix. In other words, what could you add to a matrix that doesn't change it at all? So it's just a matrix made of zeros. Not a very big deal, but later on we're going to talk about a multiplying identity matrix, which is a little more interesting. Next property is an additive inverse. The inverse of A is -A, so that if you added these two matrices together, you would get all zeros. So we're asked to find the inverse of B if this is matrix B. So the inverse of B is just whatever we would add to this that would give us a 0. So we would add a -4, a -2, and a 1, and a -1, a 2, and a -3. And then if you added B to its inverse, all you'd have is zeros. Next topic to talk about is scalar multiplication. Scalar is, the word is scale, and you're either scaling the matrix up or down. So you just multiply each element of the matrix by a certain number or fraction. And we're going to use this, if you remember in geometry, you did transformations where you made a flip, a slide, or a shrink or make it larger. Well, this scalar one does that larger thing if you scale it up by a number. So we're asked to find 4B if this is matrix B, and so you just take each element and multiply it by 4. You can check my math here and make sure I'm doing this all correct. All right, now we're going to put some of our skills together here. We're going to be asked to find 2a minus 3b, given that this is matrix A and here's matrix B. So let's just do this one step at a time. Let's find 2a first. So we're going to take every element of A and times it by 2. So I get 4, 14, 0, 6, 2, and 10. And then we're going to subtract from that 3b. So let's find 3b first. 3 times 4 is 12. 3 times 2 is 6. Negative 3. 3, negative 6, and 9. And now when we subtract these, we subtract the corresponding elements. 4 minus 12 is negative 8. 14 minus 6 is 8. And 0 minus a negative 3 is a positive 3. The bottom row, 6 take away 3 is 3. 2 minus a negative 6 is 8. And 10 minus 9 is 1. So there's the resulting matrix. Now, this table is a brief review of properties that you're probably very familiar with from Algebra 1. Don't know if you need to write it down. I just wanted to review it with you. The identity property does not change the matrix. The matrix A, if you add a bunch of zeros on either side of it, you still remain, the matrix A stays the same. Inverse says if you add the inverse of the matrix, you get a bunch of zeros. Commutative property. Now, adding matrices is commutative. It would not matter which one you start with. However, when we do multiplying in the next section, this is very, very different. So we're reviewing this just so you can be real familiar with these properties, because they're not the same with matrices as they were with regular multiplication. But addition, they are the same. Matrix addition is associative. It does not matter if you group these two together and add them first, or group these two together and add them first. Closure, if you add two matrices, and if this one is a 4 by 1, and you add it to another 4 by 1, your answer is going to be a 4 by 1, so that it is closure in that sense. All right, the next thing we're going to do is solve a simple matrix equation. And one of the reasons I want to do this is to emphasize that we do not divide with matrices. Never, ever. If we're going to solve here, we multiply by the reciprocal of the number. And so you'll see that in this example. So we want to solve for this x, get that x alone. So the first thing we want to do is subtract this matrix from both sides. And we can do that because we've already checked they are both the same size, so they can be subtracted. So if we subtract over here, we have a matrix full of zeros, which is nothing, so we still have our negative 2x. Over here, 3 minus 2 is 1, 5 minus 1 is 4, 2 minus 3 is negative 1, 1 minus 3 is negative 2, 4 minus 5 is negative 1, and 1 minus 1 is 0. So now here in regular equations, we'd be dividing both sides by negative 2. But we're not going to do that. We're not even going to start. There's no dividing with matrices because I don't want it to mess you up later. So we're going to, instead of dividing, we're going to multiply both sides by the reciprocal of this coefficient. The reciprocal of negative 2 is negative 1/2. So we're going to multiply this side by negative 1/2 and multiply this side by negative 1/2. Here we would get x. And now if we multiply every element in this matrix by negative 1/2, by the way, you can have fractions in your matrices, and you will when we Do these on the calculator also. So 1 times negative a half is negative half. 4 times negative a half is negative 2. Negative times negative is positive 1/2. Negative 2 times negative 1/2 is 1. Negative times negative again is positive, and 0 times anything is 0. So this is solved for x now. All right, you have all the knowledge you need now to do section 2. So have fun with that.